And
we're about to be in the know.
yeah. So you introduce a new, and you know when you finish, you know when you do like sine x squared plus 3 sine x, something like that, and you gotta solve it, and then you substitute you just call a sine x for ease.
Yeah.
Okay, we're gonna do something like that. Just with a u, yeah, we're gonna use u. We're gonna call u something. Now the whole thing is, what do we call u? At the end of this, not the end of this, mid this, I'm going to integrate something a lot easier in terms of u. So that means I have to have u and I have to have du instead of x and dx. Little changes in u, this new kind of function, than instead of little changes in x. So that's where the derivative comes in, because remember you think dy over dx and things like that, derivatives. If I need a du, I might need a derivative of u. So you notice straight away that this derives to this, and that is very important. So I'm going to call this one u, and something about this one might be du. But anyway, this is u. So the first thing I do is I pick my u and I write it separately. And then I derive it to get some sort of u in. Du in. I don't want dx anymore, I want du. So I derive it. So the derivative is with respect to x. So instead of dy dx, it's du dx, because usually this is a y. Now it's a u, it's a function and we call u instead of y. What is the derivative of this? 3x squared plus 2x. So this is all about substitution. I want to... Oh yes, not 2x. I want to substitute all the x's out and replace them all with u's. I can almost do it now. I'll come to that in a second, how I do that. So, I'm going to integrate the square root of, this was u. Right. But now I have this thing to get rid of. I want to get rid of 3x squared plus 2 times dx. Well, what I could do is multiply both sides by dx, yeah. So if I multiply both sides by dx, what happens is that this gets multiplied by dx, and this dx cancels here, and I have just du. Do you see that? So you can just take it that dx multiplies up here. This whole thing, then, is the same as that, exactly the same. So it can now be replaced by du. Okay? If you saw just this problem, you'd be able to do that, right? And that's what we're just going to do with a different letter here. It's the exact same thing. So what would you do? You might do a little rewrite, u to the half du, or x to the half dx. What would be the integral of this? Add 1 to the power, 3 over 2, divide down by the new power, so divide by 3 over 2. Okay, so it's the same thing over here. Plus c, exact same thing. Instead of u, instead of x, it's going to be u. 3 over 2, all over 2 plus c. Now it is integrated, but all along, u was something else, wasn't it? U, we called it this at the start. So we put it back in. X cubed plus 2x all over 3 plus c is the integral of that.
Oh, that was fun.
Wasn't it?
I don't think so.
Do we believe that it is the integral?
Well, you told us it was.
I told you, but sometimes I'm wrong. Well, a lot of times I'm wrong.
Where did the power
Where does the power go?
Oh, the power just forgot. See? So always I can check if this is the function, I can get the derivative of the function, and it should be this. Okay? So what do we do? This looks like chain rule to me. The c is going to disappear, I know that.
Is this another question?
Same question, I'm just checking my answer.
Oh.
So, derivative. Chain rule. This is 2/3 here. So 3 over 2, I need to multiply down then by 3 over 2, yeah? The old power.
Yep.
Subtract 1 from this. And then afterwards, I need to multiply by the derivative of the inside. And I rewrite. So this is all going to cancel out, isn't it? So I get x cubed plus 2x to the power half, which is the square root, times 3x squared plus 2. And that is the same. Yes.
I will refer to the other two.
Okay. We're going to do another one.
Which one should we do?
I'm gonna do them all. You're not gonna do any at the moment. We're just gonna work. Yeah, we're gonna do them. We just want to do this first. Let's take it easy because this is important as well. What do I call you?
Oh,
This is part of the skill in integration by substitution. Picking the right u, and then because it has to be very specific, it has to all disappear. It has to go from x's to u. You can't have anything else in there. You can have numbers, constants, but you can't have any x's in here. So let's say we do pick u is e to the 1 minus x squared. Let's say we go with that. Let's say we go, Aiden, calm down. Let's say we do that, and we pick that. What do we do here? We differentiate it as soon as we pick the u. We differentiate this u. Yeah, it's going to get worse, isn't it? It's e to the 1 minus x squared multiplied by negative 2x, isn't it? That's the derivative. And then if you, yeah, that's actually worse than I started with. So I can't pick this. So what's the other thing I can pick?
X.
Okay, we can pick x. If this is x, the derivative, yes, that's brilliant. It goes away. At least there's no more. But how can I now I can rearrange this, du just equals dx. But if I sub in for u, I get u, x is u, e, o. No, I don't want that. 1 minus x squared.
U e 1 minus u squared.
U, e, yeah, it will be.
So it would work.
You can integrate that. You're good to integrate. That's an easy thing to integrate. No, it's going to be e 1 minus u squared, which is the same problem again. So the last thing I pick is actually the power in this case. If u is that. U is that. So one of the things when you have e to the power, pick the power usually for it. And you'll see how it works now. Du over dx, the derivative of this is negative 2x. That's not x though. I want x dx out of this. Because then I can replace dx with something. With u.
Can we divide u by -2?
Yeah. So the first thing I'll do is probably just do this. So I have x dx, but I have minus 2x dx. And then if I divide everything by -2, or write negative a half, some people prefer, I have x dx. Does that make sense? Or divide over -2, if you like that.
Which means we would have to change u as well, right?
Well, let's write this. If you want, you can rewrite this initial statement as e 1 minus x squared times x dx, if you like that. And now I'll rewrite this in terms of, I'll do the substitution part. U is this, so this is e to the power of u, and x dx is now a half du. And now all my x's are gone and replaced with u's.
So you can just take the constant out of it.
Yes, I can always pull the constant out, or I can just deal with it as negative half in here. So I have two options, and these are all the same as this. I can have the half out in front here, e to the u du. I can write it like that, or I can write it negative a half e to the u du. All these three are the same way of writing the same thing. Just whichever one you prefer. Most guys like mathematicians, like to do this, not non-gender guys. But we can go from here, here, or here. You're going to get the same answer. What is the integral of e to the u?
E to the u.
It's just e to the u. It's an easy one. And minus a half e to the u is just minus a half e to the u, isn't it? Plus c. And all the hard work has been done in the substitution part. The easy part is now the integration part. And u is e to the 1 minus x squared from the start. I called it that up here. So this is my answer.
Do we write f(x) equals?
You could, yeah, or y equals, or whatever, yeah. Or this is just a straight integration. There's no context, so you just write it like that. It's fine.
So does that mean the previous one's f here?
Could be. Not going to say that though. All right, let's do one of the trig ones. Which one? A, okay. So we want to integrate cosine cubed x sine x. Okay, integrate that. Change color of pen just for fun. What do we call u and what do we call, well, what do we call u?
Sin x. U.
Sine x?
I think sin x.
Okay.
Let's expand. Charles, is that up right?
185. Who is that?
Charles calling you.
Who's 185? That's
Wait,
Very-
what?
It's just 185 is calling me. No idea.
Tax on. Have you paid your tax?
I have paid my taxes, yeah. I'll have you know, yeah. All right. So if I pick u to be sine x, don't write this down. The derivative of sine x is cosine x, which means du is cosine x dx. Yeah?
Du squared equals cos.
Yeah, I think I'd rather have this bit together and then just do u cubed. So I'm going to start again. You had a 50-50 chance. Now, do I pick cosine cubed or do I pick just cosine?
Just cosine.
Just cosine. Why?
Because you said
Because you can cube it easier.
Because it will derive to being just sine. Okay, so just cosine x derives to negative sine x, though, doesn't it? Just be careful of that. And then du is negative sine x dx, which is okay. I can replace that if I just go negative du is sine x dx, yes? So now this can be replaced. This is negative du, and this is u cubed, isn't it? Because another way of writing cosine cubed x is cosine x cubed. It's the same thing. Right, so now I'm going to get to back to integration. I've done some derivatives. So it's u cubed, cosine x is u, so it's u cubed. Negative du, so I can put maybe put negative here or put the negative outside. It's up to you. It'll all work out the same way. And now what is the integral of u cubed? U squared? Yeah, that'll catch you. Did I say derivative? Oh, oops, yeah, integral of u. All right, and then we can replace u again, negative cosine, or maybe you write it the same way we did, cosine to the 4x all over 4 plus c. We picked cosine, yeah we did. All right, let's do the last one.
This is stressful.
Easy.
The first one, you would also
I was like,
write
this is stressful.
I thought you were going to say
u
u
is
is
equal
equal
to
to
e negative e 1
Like,
by
I've actively
squared.
done trying to go.
In the first one,
Yeah.
Maybe it's time for you to get a ball.
this one,
No, the one on the right.
this one.
Bring that back, bring that back.
That would still work.
Can you
If u is e 1 minus No, 1, because it'll derive to something horrible. It might work, yeah, but... Oh, you did? Was my way easier? Or...
Just say, because then you just get negative 1/2 u, and then use that whole thing.
Oh, okay, yeah, you can do that. Yeah, you're right. Okay. Don't worry, that'll only confuse the issue right now. What are we doing? Cosine x over sine x. It's 50-50 shot. 50-50 shot.
I think sin x.
You think? Let's do it.
But can I write this in my book?
Oh no, don't take it down.
No, it's gonna be right. Watch it.
Okay, du dx is cosine x. So du is cosine x dx. Do we think we're right?
Yeah.
That's not
Well, it has cosine x dx. So what's my integral going to be? 1 over u du. That's okay. And you said it. It's going to be, yeah, ln absolute value sine x. Easy. Easy. Integration by substitution. Piece of cake.
It's so much easier living with this.
There you go.
So,
Yes.
please apply.
Please upload that video. I will, yeah.